A question I've been asked a number of times is what I would do if the battery failed in my EV. That friend has heard that new EV batteries are insanely expensive and wonders how I would cope if that were to happen to me. So today I intend to answer that question. First I'll discuss how likely that is, then I'll explain what I would do and how expensive that might be. Hello everyone, I'm Andrew. Thanks for joining me on the electric transition. Today I'm going to discuss the subject of battery failures in EVs and whether that is something we should worry about. Firstly, I should explain that there are two batteries in an EV. There's one under the bonnet, a low voltage one, usually a lead acid battery, a bit like the one found in any other type of car. Lead acid batteries are consumables. They need replacing every 3 to 5 years on average. That's cheap to do and is pretty much the same as for a petrol or diesel car. The second battery is the high voltage traction battery used to drive the car forward. That's the one that people worry is very expensive and is the subject of the rest of the video. The traction battery, usually a lithium-ion battery of one form or another, is very high capacity and that's what makes it expensive. Traditionally, the traction battery could be as much as a quarter of the cost of the car, although note that's cost, not price. The cost of the materials used to manufacture a car is quite a lot less than the price we pay for it, but even so, it's not cheap. That is why people tend to worry. Aware that the lithium-ion batteries in their mobile phones lose capacity in just a few years, they fear that this could also happen in an EV. Firstly, let me address that. The lithium-ion battery in your phone is not the same as the battery in a car. When it comes to our mobile phone, we want it to be really thin and lightweight, have a long runtime, but also charge really fast. In order to achieve all three of those things, mobile phone manufacturers use batteries with very high energy density, built using very aggressive battery chemistries. Those chemistries do lose capacity quickly, it's a limitation of them. However, it's thought not to be too much of a problem in a phone. After all, a phone isn't intended to last for a long time. Most people change phones every 2 or 3 years. A car, on the other hand, is a very different use case. Weight is less important as we do not carry them around, but we do want really long life. Therefore, the manufacturers of cars use different chemistries, ones that do not suffer degradation at anything like the same rate. We call them all lithium-ion batteries, as if it's a single thing, but it's really not. Instead, lithium-ion represents a family of battery chemistries with different tweaks available to achieve different characteristics, and vehicle manufacturers go conservative with their choice of chemistry to ensure long life in their cars. But there's also another difference, and that's the battery management strategy. In other words, how the battery is allowed to charge and discharge. In a mobile phone, space is at a premium. The battery is shoved in the case, sat right next to the very hot processor, with little regards for the battery's longevity. As a result, the battery can get very hot, especially during charging, and that heat really accelerates degradation. That loss of runtime we're used to in a phone. An aggressive choice of chemistry plus no thermal management is what causes high degradation. In a car, on the other hand, things are quite different. There's space for a cooling system and indeed a bit of heating for the winter, and so that's all fitted by default, these days at least. One of the earliest lithium-ion cars on the market was the Nissan LEAF. In the LEAF, they were struggling to keep costs down, as that many years ago batteries were insanely expensive. As a result, they did not add a cooling system to the battery, and that car did suffer from quite high degradation for a car. The LEAF is the car that proved to manufacturers how important cooling was, and no other car has been built that way since. As a result, we don't see very high degradation in EVs anymore. We do see some, occasionally a couple of % in the first year, and then maybe 1% per year after that, but that's not all that noticeable. So far we've been talking about degradation, a slow loss of capacity over the battery's life, but there is a second thing that can happen. An EV's battery pack is made up of multiple cells, usually hundreds, and if one of those cells goes weak, then the battery pack as a whole can act badly. The battery acts like a chain, and the weak cell would be the weakest link in that chain. The whole pack can be held back by that one cell as a result of the imbalance between them. Whilst that does happen occasionally, it's really rare. However, this is a more serious problem if it happens, because the car could even stop before the displayed range reaches zero. That's not something anyone wants. It's this sort of failure mode that people are really worried about when they fear battery failure. A bit of reduced range over the life of the car is manageable, it's predictable and slow, but the car just stopping could be scary. The good news is that this type of failure is rare, very rare. Indeed, it's so rare that manufacturers warranty the battery against both severe degradation and cell failure. Yep, there's a warranty for that, a long warranty. It used to be that the battery warranties were for 7 years or 100,000 miles, but in fact that's now gone up in the UK. As you may know, we have the ZEV mandate in the UK, which places requirements upon manufacturers to sell EVs, but not just any EVs. To avoid them being tempted to sell cheap tat, the mandate contains minimum standards that cars must meet to qualify as a sale counted towards their target, and that includes a longer battery warranty. The text of the ZEV mandate is made clear in a response document written after consultation with manufacturers, and it's written in plain English there. The battery warranty must be a minimum of 8 years or 100,000 miles, whichever comes first. But that's only the warranty. We can expect batteries to last much longer than that. They won't fail straight after the warranty ends. With such a long warranty period, it would be too hard for a manufacturer to engineer that. They don't want to risk warranty repairs because that would cost them money, so batteries will last longer than that. And indeed they do. There are always EVs from 2011 and 2012 available for sale, still merrily running around with functioning batteries, albeit with the small ranges of those early cars. For those of a particularly nervous disposition, there are now companies offering extended battery warranties too. Warranty-wise, for example, will warranty EV batteries for up to 15 years old for the right price. And I'm sure they're not alone in that. It's just that they were the first one I found, given the most cursory of glances. To be clear, I have no affiliation with them at all, and I don't have an extended warranty myself. Okay, so failures are rare. We have a long warranty from the manufacturer, and extended warranties are an option too. But let's say, for sake of argument, that you do suffer a failure not covered by any warranty. What then? Well, this is where we can draw on any existing experience we might have. Let's ask a question you might have asked in the past. What would you do if the engine in your petrol car were to fail? What then? That's not a flippant question. I'm not avoiding the original one. Instead, I'm trying to use this to help inform us. So what would you do if an engine were to fail in a car in the past? Your first answer might be to write the car off, and I think that's one thing we might do with an EV. If the car is worth next to nothing, then we might choose to do that. However, if we didn't want to do that, if the car still had some value, either financial value or sentimental value to us for that matter, what then? What's the alternative for a petrol engine? The answer that springs to my mind is the word reconditioned. We would fit a second-hand engine as a replacement, one which had been checked or reworked. That's got to be an option. After all, we probably wouldn't fit a new engine to an older car, would we? That would be phenomenally expensive. And so it is with an EV. Yes, a new battery could be eye-wateringly expensive, but not so much a used one. But I want to continue the analogy a bit further. How much work do you think is involved in each job? what might the labour costs be of each? In a combustion engine car, the engine is heavily connected to other things. To get the old one out, there is quite a lot of work. First, we need to drain the cooling system and disconnect that. Next might be to drain the gearbox oil and then disconnect the drive shafts. We've also got to disconnect a bunch of individual electrics, lots of wires to sensors and actuators, as well as to the ignition system. Disconnecting the fuel system is a must, although that's fairly straightforward, as is disconnecting the exhaust system and the air intake. We might even need to remove a few ancillaries, perhaps the alternator or the water pump, depending on what's in the way. Even the 12-volt battery might need to come out, as well as its tray and perhaps even a fuse box under the bonnet. With all that gone, we can undo the engine mounts and lift out the engine. Finally, as they say in the Haynes manual, refitting is the reverse of removal, which makes it sound way easier than it is. There's lots of labour there, a lot of hours used in prep and completion, and that is expensive. The cost of fitting a reconditioned engine is not small. Let's now consider changing an EV battery. We start by making the car safe, by doing a disconnect inside a hatch in the car and then checking that the voltage is gone. Simple enough so far. An EV battery also has a cooling system these days, so as before, that needs draining and disconnecting. Then there is the high voltage connections, positive and negative, usually in a single connector, which simply unplugs. Next, there's a low voltage connector to unplug as well, a single extra connector to disconnect. Finally, there's an earth strap held on by a single bolt. With that disconnected, we're ready to remove the battery from under the car. With the car lifted and sufficient support under the battery, we remove the bolts holding the battery to the car, usually 6 to 12 of them, and drop the battery down. The battery is very heavy, hundreds of kilos, so that's got to be done with care, but with the right equipment it doesn't take long. Given a little experience, the battery removal takes an hour or less. Hopefully it's clear that there is a lot less labour required to remove and refit an EV battery than there was for a petrol engine. Less labour means less cost. Once the battery is out of an EV, there are two options. The first is to repair it, to replace a module or cell within it. Some people will do that. However, it's probably more common to swap the whole pack for another one, a second-hand one from another car, one that has been scrapped. Packs for most cars are relatively easily available second-hand. There's a whole host of vehicle dismantlers offering them now, and with decent availability comes competitive pricing. Here, for example, is the battery pack for an early Renault Zoe. This is from an old car, so it isn't ideal for mine, but there are packs for mine too. Here's a listing for one of those. This might be a bit overpriced compared to a few others I saw, but this listing has a nicer photo for use here than was included on the others. Alright, so what have we learnt? First, we discussed that failures are rare. You would have to be extremely unlikely for it to happen to you. The batteries in EVs are heavily tuned for and managed for longevity. These variants of the lithium-ion battery are not like those in your mobile phone, and furthermore their temperature is very carefully controlled to achieve long life. Degradation does happen, but does not result in the need to replace the pack. Even if it were to get bad, the initial manufacturer warranty is for 7 or 8 years and 100,000 miles. What's more, extended warranties are starting to become available after that for those who want them. Individual cell failures or weakness are very rare. If it happens and a car needs repair out of warranty, then fitting a second-hand one is a good option. Just as you would in an internal combustion engine car, you are unlikely to consider fitting a new unit as a replacement, not at your own expense anyway. Used replacement batteries are reasonably available and pretty reasonably priced. What's more, they are pretty quick to swap, much quicker than the engine of a petrol or diesel car, which keeps labour costs reasonable too. So in answer to what I would do in the event of my EV's battery failing, I say that I'd do what I'd do in the event of the engine failing in a petrol car. I'd probably fit another one, but a second-hand one, not a new one. As a result, the price of a new one is pretty irrelevant. What matters is the price of a lightly used one, and that's quite reasonable. Thanks very much for joining me today. Your questions and comments on this subject are most welcome in the comments section. I'd really like to hear your thoughts in the comments. Does this idea come as a surprise to you, or is this what you had in mind too? Is there any reason why you would not fit a second-hand battery from a more recent low-mileage car? And tell me, are you someone who would consider getting an extended warranty? If you've liked the video, then it is a big help to me if you click the thumbs up button. And I'd love to have you as a subscriber of the channel if you want to see more from me. Thanks.